In this example, we're going to be using a plotting approach to try and find out the draw the graph of a straight line in the number plane. Now, this equation here is very typical of the equation of a straight line. We'll meet lots of these in this unit. You can draw its graph using this approach. The equation tells you that the y value is equal to 2 times the x value plus 1. So what we're going to do is get some different x values and find out what the y value is. Then we're going to get those x, y points and put all the points on the graph. So what we've done is we've ruled up a table here and we've got some different x values here. Now you could have chosen any that you like. These have been chosen for us, so we're going to use these. We're going to get these x values and put them into the equation instead of x and work out what y equals. When x equals 0, y will equal 2 times 0. So 2 times 0 plus 1. I'll just write it like that. That means 2 next to the 0 means 2 times 0. Now 2 times 0 is 0. Plus 1. 0 plus 1 equals 1. So in other words, when x equals 0, y equals 1. That means that the point x equals 0, y equals 1 is a point on our graph. The point 0, 1 is on the graph. Let's find some other points that are on the graph. When x equals 1, we can work out what y equals by putting x equals 1 into this equation. Y equals 2 times 1 plus 1 more. 2 times 1 is 2 and 1 more is 3. When x equals 1, y equals 3. So in other words, the point x equals 1, y equals 3 is a point on our graph. When x equals 2, what does y equal? Y equals 2 times 2 plus 1 more. 2 times 2 is 4 and 1 more is 5. The point 1, 5 is a point on our graph. And finally, when x equals 3, put x equals 3 in here and work out what y is. Well, y equals 2. Instead of x, I'm going to put 3. Times 3 plus 1. 2 times 3 is 6. 6 plus 1 is 7. That means that the point 3, 1, the big one, 3, 7 is on our graph, and I've made a mistake here, haven't I? That was the point 25 is on the graph. Okay, that's all right. We can draw these points now. Now, our x values have gone between 0 and 3, so let's just make our x values go 0, 1, 2, 3. That's enough. And our y values have to get up to 7. That's okay. We can go 1, 2, 3, 5, 6, 7. And we can plot them on the graph. The point x equals 0, y equals 1 is on the graph. The point x equals 1, y equals 3 is on the graph. The point x equals 2, y equals 5 is on the graph. And the point x equals 3, y equals 7 is on the graph. Can you see that we've got a straight line of points there? We can rule a line through those straight lines. Now, in the examples that you do in this course, you're going to find out that all of your examples are straight line cases. So if you get one and you find that the points aren't quite on a straight line, or you've got one point hanging off or something, then you've probably made a mistake with that point, and you probably should check it again, because all the ones in this unit are going to be straight line cases. Okay, now we're going to do a similar sort of thing, but this time we're working with the extended number plane. In other words, not just positive values of x and y, but the possibility where some of them could be positive or negative values. So we've been asked to draw the graph of y equals negative 2x plus 3, and for these suggested x values. So what we're going to do is get each one of the x values, pop them into the equation instead of x and work out what y is. and then we'll have an xy point which is on the graph. So when x equals minus 2, y will equal negative 2 times negative 2 plus 3. Negative times negative equals positive. That'll equal 4 plus 3, which equals 7. The point negative 2, 7 is a point on our graph. I could put these on as I go, or I could work them all out and then put them all on at the end. I think that's what I'm going to do. So when x equals minus 1, y equals negative 2 times minus 1 plus 3. That'll be positive 2 plus 3 is 5. The point minus 1, 5 is on the graph. When x equals 0, y equals negative 2 times 0 is 0 plus 3 is 3. There's another point on our graph. When x equals 1, y equals negative 2 times 1 plus 3. So that equals minus 2. Minus 2 plus 3 equals plus 1. 1 is on the graph. When y equals 2, minus 2 times 2 is minus 4, plus 3 is minus 1. The point the point 2 minus 1 is on the graph. And when y equals 3, when x equals 3, minus 2 times 3 is minus 6. Minus 6 plus 3 is minus 3. When x equals 3, y equals minus 3. You might notice a pattern which begins to form with those points too. It's good if you notice that. That can help you check what you're doing. So we've got negative x values go between, start at minus 2 and go all the way up to 3. And y values have got to go from 7 to minus 3. I think this is organised nicely for you. 1, 2, 3, 4. I'll just put a 5 there. That'll help us find things. The point minus 2, 7 is on the graph. The point minus 1, 5 is on the graph. The point 0, 3 is on the graph. Point 1, 1 is on the graph. The point 2, negative 1, and 3, minus 3. And I think you can see I've got a straight line of points there, and I can rule a straight line through them. Have a go at doing some of these yourself.